All right. So, hello. This is my second time going through this because I totally screwed up the first time. Did a nice long form video, and I guess I had pressed start on a preview screen and not the real screen. Here we are. Motorcycles, motorcycles, motorcycles. I'm making a motorcycle. All right. Um, I needed a palate cleanser. I needed to mix things up. I've been doing bicycles for a long time. And I mix in skateboard trucks and everything like that. But as I tell people all the time, I do bicycles, motorcycles, and skateboards. Well, in recent years, people haven't seen a lot of motorcycle stuff. But motorcycles, I love motorcycles as much as the other stuff. Um, I, 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 I've always been. It's like a deal with the devil. A motorcycle is a suicide machine. If you want to die, get on a motorcycle. They are wonderful, wonderful machines, just like bicycles, just like skateboards. And I have certainly had a lot of fun on them in my life and almost lost my life on dozens of occasions. But anyway, I'm an old man now and I just need to mix it up. I need some new ideas, some fresh things going in my head. So I'm making a motorcycle, full-size motorcycle, all that, trying to have it useful highway speeds. But instead of internal combustion, which I was never really into when I was younger. I like the motorcycle, not the power plant. You know what I mean? So suspension and gearing was all stuff I was into, but not really. I power, whatever. I'm a mortal, so there's plenty of power, right? And so I'm doing an electric because there's a lot to learn. That I really do need to learn because it's the modern world. This is how all the drones around us work. This is how electric cars obviously work, and scooters and mobility devices and all that stuff. It's just everywhere now. And learning the basics, you know, proper basics, in a real project is helpful. So this is going to do it. That's for sure. I've learned a lot just already. Um, but the motorcycle part. So here's here's kind of what I'm doing right now. It's a chopper cruiser type thing. Seat is approximated. It looks better than that. It's a typical Harley type saddle, single person saddle. Swing arm's not modeled, but everything else is. Massive controller, tiny batteries, small motor. I think if I was getting great full current to this motor, it's going to effectively get me at about 60 miles an hour, something like that, 65. Um, with the gearing that I've got and everything. We'll see how things play out in testing, but this is what I'm starting with because it's easier. Later in another generation, hopefully move to full power. But of course, are batteries are the biggest constraint. I mean, we figured out electric cars back in the like early 1900s, like in the aughts, like 1904 or whatever, I can't remember, or maybe even in the 1800s we had electric cars. Um, and the reason why gasoline took off over electric is exactly the same reason now we have problems with electric as it was then. Batteries. Batteries suck. Batteries are the problem. We need energy density to be from where we are now at least cut in half, if not more. If that happens, everything becomes truly viable. Right now, it is kind of make pretend. All right. Um, but there's ways of doing it. It's just they're expensive and we're making odd choices, right? Anyway, so here's the thing. I'm putting a steering damper up there because it's on the GSXR because it's a race replica. And I'm trying to remember, in some racing classes, you must have a steering damper, so they include it. Even though if you're using a steering damper just in general suspension practice or chassis steering practice, you're making a massive mistake. I guess if I'm going to nerd out on steering dampers, you should tune your motorcycle without the steering damper on there. So once your tuning is done, you can put it there and make it uh, as invisible as you can. But that's a steering damper is not a tuning tool. Um, but okay, let's talk about what we're here to talk about today. In the last post, I talked about the kinematics of this system of the linkages, but now we're talking about the placement of this countershaft sprocket. I'm using the term countershaft sprocket because that's what I'm used to. That's what I've been saying for years. That's what we know what it means. In the current world, in this, I mean, while there is a reduction here, I don't know if countershaft is the correct term. We have to figure that out. I haven't been dwelling on it right now, but if I say countershaft sprocket, this is what I mean. It's the front sprocket. Rear or driving or wheel sprocket, that's back here. Okay. Let's go to, we can leave that there, but right here. Whoops. Didn't rewind that. Okay. This is the trailing arm in various positions. We have the initial position here that's full extended. Then we have sag, which is 37 millimeters. Okay, we got to talk about this. I'm denoting travel as movement around an arc, a radial travel measurement. Now, this is maybe confusing, but there's some ambiguity in this space where if a manufacturer like Suzuki says for their GSX-R 600 that has 130 millimeters of rear wheel travel, what does that mean? Is it 130 vertical millimeters of travel? Is it 130 millimeters around the arc? Is it point to point 130 millimeters? We don't know. They're not telling us, and um, who knows, right? So when people quote travel numbers, there's a lot of ambiguity out there. Now, somebody else designing the system might say, oh, vertical wheel travel is what we're talking about. Okay, well, that might be true if you're quoting or trying to talk about the specifications of a vehicle. But when we talk about the engineering of the system, when we're talking about wheel travel, I don't think vertical works out. And there's a number of reasons that I talk about in the blog post. I'm switching to radial. And I think that makes more sense on an engineering level. Now, we can always parse out the vertical component there if we'd like. We can do the wheel path and all that sort of stuff. So we can always get that component, but the thing is, from an engineering sense, I think it makes more sense to talk about the radial motion. And this is why mid position of the wheel about the arc becomes very important when we're talking about countershaft sprocket location. Okay, let's go down here. We got the linkage system here. I'm just showing it. I discussed that in the previous post. But let's say we're trying to predict where we or place our countershaft sprocket. We have a problem. When the wheel goes through its travel, let's say this is the smallest pathway. This is the pitch diameter, so the center of the chain going about the system at min and max. We got 124 millimeters of travel here. Yeah, in this situation, I've chosen 124 millimeters of travel. GSX-R 600 says 130. We'll see where that number comes from. There might be some nuance to that. But since the damper has a 62 millimeter stroke, by going to 124, that's 2 to 1 in terms of leverage ratio average throughout the system. Now, in the previous post, I do show exactly the instantaneous leverage ratios and how that works with the linkages. But here, I've made some pretty easy math, and we're definitely in an area of leverage ratio that works out fairly well. We're not moving too fast. We're not over leveraged, blah, blah, blah. So 2 to 1 is pretty healthy for the system, and 124 millimeters of travel, about that. And vertical, it turns into like 123.9 or something like that. In this position is perfectly good for a cruiser or a chopper. In fact, it's way better than most if you're talking about quality travel. Um, so here we are, and we look at this stuff, and we look at the min and the max, and we follow it around and say I'm at 15 tooth front sprocket, which I don't want to use. I want to use a 16 at the very minimum. Um, and I'm at a 45 millimeter tooth sprocket in the rear because that's going to be the smallest typically that you'd run on a G6R 600 LM rear. Um, if we go over here, 65 millimeters, that's how much space there is for the trailing arm physically. Like you can't go into there because you'd be cutting metal. And if we have a 15 millimeter chain, half of that is 7.5. This outer ring here is the clearance ring. Notice we're just tangent to that in this situation. I've moved the countershaft sprocket out 92 millimeters because that's as much as the minimum I can do while allowing an 18 tooth sprocket. Um, and so everything's close and tidy. This uh, half a degree here, that's the angle at mid stroke here, and we're along that angle. So in many ways, if we're talking about countershaft sprocket location, there's really only one path it can be on, and the distance from there will have some slight effect, but there's no choice, is what I'm saying, if we're going to have a true wheel clearance position. Isn't that interesting? Because I kind of had always assumed I had a bit more choice, and I have no choice. Here I've done in a maximized situation, that 18 tooth sprocket is now in place in the front, and in the rear 54. That's about the largest you can easily get in a 520 for G6R 600 LM, and I could go maybe bigger than that, but it's not going to be convenient or easy, so I'm considering 54 as my max. But you say even there, I'm 9.6 millimeters away at my extremes. That's fairly close. That's like this much. And if the chain's bouncing around, you've got some crazy stuff happening. Um, Now, granted, these are at limits. When are we driving hard under full compression or full extension? Well, it may happen, but we're considering it. We're thinking about that. And, you know, a manufacturer, like if you've seen a motocross bike in a paddock, um, the chain might be folding over that trailing arm node when it's at full extension. Well, the engineers and the tuners that are working on that are making a lot of compromises. How much life is available, how many wear items have to be replaced, and how often. Also, is more travel just more? And is that what's really important here? They have to decide in a very real world way what they compromise on. Here, I have a bit of room to work and choices I can make, and I'd like to start with an elegant system before I get into the less elegant systems. But that's interesting, and that's something I hadn't really drawn out in real life to this level where I go, oh my gosh, once I've considered all the variables, I don't have any choice about where it goes. It goes there. Um, well, what this tells us is like if we're designing the system and we're starting to look at our squat and anti-squat type characteristics, the only way to really change these values of the anti-squat angle and the anti-squat height um, are by changing the trailing arm node height. Like if you want that different at your end result, change the node height. Don't be moving the sprocket around because it's going to fall within a very constrained area. So and I don't mean to imply that you take a production bike and use an adjustable swing arm situation. That's something we're very specific Superbike or MotoGP type situations where they understand what they're doing. But no, I just rock the whole system about the axle, so I can change that height without disturbing the relationship of the sprockets and end up with very different positions of this anti-squat angle. So when we look at this is the calculations for the anti-squat, typical geometric methodologies rather than torque values. That height here, and this is about where the front wheel is, and this is the angle of the intersection and blah, blah, blah. If my center of mass is above this line, then my system is going to squat under load just slightly. And if it's down here, it's going to jack. Okay. I believe that's correct. I'm sure that you'll pick that up. Anyway, one side of the line or the other, and we're making decisions about center of mass and where it is. That will affect this system. Great to know. Here, it's about the height of that rear wheel. Now let's look at it. There we go. Within the bike. Okay. So here it is on the bike, and we can see that that line as designed when the bike is sagged is right about the height of the tops of the tires and the saddle. Interesting. I played a bit around with all this stuff, making decisions. Now I'm imagining stuff. I don't know where the center of mass ends up. I'm a bigger guy, 230 or whatever pounds, and most of my mass is going to be up here. But there's a lot of heavy parts down here, especially batteries. That's another thing with electrics is the battery mass is a huge consideration compared to internal. But there was gasoline with that, and whatever. We'll figure it out. If I was at a bigger manufacturer, I could know this stuff better. Anyway, I'm figuring my center of mass is going to be close to this line. Now, whether it's jacking or squatting, at least it's not significantly off, and I've considered it. On the first prototype, I'm hoping this makes sense and works out well. We'll know and we'll make changes accordingly. But I wanted to talk about that, and I'm showing this here. I wanted to talk about it because this is fascinating, and I think more people need to talk about this when they're talking about either hacking an electric into an existing motorcycle or making their own. This stuff's really important. And if you watch YouTube, especially some of the more hilarious videos, um, this doesn't make sense on any level. So yeah, pretty cool stuff. And there we go. So I'll see you at the Made Bike Show, and I hope this clarifies the post that I wrote. Okay.